We are ready when you are. Who's from the CAP team. We have now Sebastian, who is architect for the CAP team, and he will talk about the native OData adapter for CAP Node.js and covering design principles, the architecture, and the workflow of a request, along with performance analysis.
Oh.
Have fun.
Thank you. That's the first thing I have to start off. I had applied for 40 minutes. I only got 20. So this description is kind of too much that I can cover now. I didn't update it. And second disclaimer, it's going to be very unconference style, as it's supposed to be at reCAP. So I have a couple of slides, but I'm going to demo a lot, and we can do some Q&A afterwards. Yeah, so I wanted to start with a brief history and motivation why we are actually doing this. And I chose the name native OData adapter instead of new, because it's not just like we're overhauling something that we built ourselves, but the history of the OData adapter in the CAP Node.js stack is actually that there was, and now this is basically people that recognize these names. They have been working with CAP for a long time. So there was an SAP OData server, also called OKRA internally, basically. And we used that. It was started in around 2018, 2019. And because you have to kind of choose your battles in the beginning, right? So we said, okay, we're gonna work with this and focus on other areas. Unfortunately, though, this thing was discontinued in 2020. And then we took it, copy paste basically, and put it into another thing that no longer exists anymore. That is SAP CDS minus runtime. Right now, you only have SAP CDS. We merged all of those things together a couple of years ago. But if you recognize these OData server and CDS runtimes packages, then you're a CAP veteran, definitely. And yeah, as I said in the beginning, you kind of have to choose your battles, where you're going to go. You want to get out quickly. So we took this existing piece of software, this library, but it never really was a great fit for us because, CAP, you have your service definitions, you register your handlers, you act on events that come in. Well, this OData server actually followed the same principles, right? So you gave it an EDMX and you gave it an Express instance, and then you basically registered handlers for callbacks. So basically, we as CAP offered you the possibility to register handlers, but we ourselves had to register our own handlers in this OKRA framework. Then the second point is that as a really static OData server, it was really always focused on EDMX. And EDMX is the format that, of course, you need to provide via your $metadata endpoint. But at runtime, when you are working with CDS entities and queries and stuff like that, this EDMX is not really so useful. Yeah, you need a season definition. So that's also one thing. Now the new adapters, they serve this EDMX on the $metadata endpoint, but other than that, they don't use EDMX at all. They're completely focused on season. And then the last thing is that this OData server was never really meant for these extensibility use cases. So feature toggles, UI flex, tenant extensions, stuff like this. So everything where you at runtime get a model augmentation means you have to recompile to EDMX. You would have to start and delete instances of this protocol adapter. So yeah, that's what we do right now, but it's kind of, we did in CDS7 because that's basically the thing. This one, the new one, you're going to have, as Daniel announced this morning, as the default in CDS8. And there it's going to be a lot more flexible going forward. So again, it was discontinued in 2020. So we started, okay, 2021, we have to build our own thing. So we started in Q1. We have this, we started building a new parser based on now Peggy. Back then it was Peg.js, so you really can specify this OData syntax, and then from this OData URLs, we can basically directly produce CQN formats. Yeah? So again, another intermediary format that was understood by the OData server is gone. Yeah? So they took the URL and put it into their OData request API, and then we had to use that API to create CQN out of that. So that's no longer the case then. And then Q2 actually, we started with a REST adapter using this new parser. So it's very much OData style. So some stuff like $apply, it doesn't do because that's not defined in the REST, but you can do the same filters ordered by stuff that you know from OData, also using the REST adapter. Yeah, and then other priorities kicked in because we had something that was working. And that's always the problem if you want to have time and spend energy on stuff that's already working, then you're going to be, no, you don't have to do that. You're going to do something else now. So time went by, but finally Q3 last year, we really started kicking off the development of this new OData adapter or native OData adapter. And yeah, again, it's going to be the default in the CDS 8 that's going to come out. So mid-June, we want to have like a first release candidate, and end of June, we want to come out with a real CDS 8 version, and there it's going to be the default. One thing that may come out or may not come out is a joint base protocol adapter. We're still in the phase of it right now. Implementation detail is, yes, we have a base adapter. It's used for REST and OData. The question is, does it make sense to have something like that if you come up with more protocol adapters? So for GraphQL, probably not. We don't know yet because there you typically have one endpoint for the whole server and not one endpoint per service, which you have in OData. But one adapter we're also playing around with a little bit is we call the HCQL adapter, which basically kind of like GraphQL gets a JSON representation of a CQN, a ready-made CQN, that it can just execute, which is then optimized for benefit from a base protocol adapter. So in a couple of months, maybe we'll announce this, and then it can help create more adapters for other flavors. Okay, so when it comes to the design, and I think I'll definitely show that in the coding also, is the question basically, what is a protocol adapter in CAP? Because you typically have your models, you have your services, there you put really your handlers in before write or before create and after read or whatever you do. So that's really the core of your business logic. So the question is now, what does the adapter actually have to do? And for us, it came out that really because Express is our server tool or server framework. So we use that, and in Express, if you want to serve something, you create basically this intermediary router object, which is kind of like an app in an app, and then you tell it to serve a specific path. Right? So you can basically say that this protocol adapter is just one of these Express middlewares, and it has certain responsibilities. For simplicity, I'm going to ignore things like extensibility right now, because finding the right adapter for your current request with feature toggles is a little bit more complex. But saying you know which router instance is supposed to serve the request, what does this thing have to do? First of all, it should check, is this request valid? Is it authorized? If not, I should not spend any time parsing anything. I should really just reject it. So that's the early access check. Then you need to do some parsing. And then when it comes to OData, because it has batch requests with atomicity groups that can be bunched up sub-requests in the overall batch request, you have to deal with these transactional boundaries. So you have to say when you're going to start a transaction and also when this transaction is going to be committed or not. So you have atomicity between these or for all these sub-requests. Finally, we have from the parsed URL and the parsed payload, we have to create these CDS request instances, and those we actually then dispatch to the service. In this case, a CDS application service instance, right? It has a little bit more features than a CDS service instance. And then your handlers get called. And at the end, at some point, it's going to reach our generic handlers, go to the database, whatever. And then at the end, either good or bad, the protocol adapter will get like a response to the whole thing. So we'll either catch an error or get a result. It has to do serialization of all of this and send it back to the client. And yeah, if you kind of have these, try to narrow it down to these 5 things in mind, maybe you can now look at one of these adapter codings. So this is really, I hope you can see it or read it good enough. So yeah, this is really live look at what is running. And you see at the top, we have like a little bit of stuff that you need for metadata, for service documents. So this kind of things that aren't really the kind of static requests that the UI does in the beginning to get the stuff, but afterwards not really in focus. And then once you have those at the very beginning, you now have these different steps that you have to do. So first of all, we have to parse, because we first have to know, is it actually a batch request or not? Or it could also be a streaming request. A streaming request when you can just really pump media data into the service. So those are the things you have to do in the very beginning to distinguish what has to be done next. And then once you've done that, you can really either handle the batch request if the URL path ends with $batch, or at the end, you're going to get all these different handlers for actions, functions. So those are the first 2. Handled both by the operation middleware, or then the create, read, update, delete. Update in 2 flavors. You have put and patch, and then also you have a read stream in there as well. And at the end we have our error middleware. So this is very much, if I would have showed you, or in comparison, what we have to do to register our handlers in this OData service, this is very, very much straightforward, right? You just have really kind of a top-down definition of which request gets routed to which middleware and where are these things going to be handled. Yes, so one final thing, I'm going to go here. Okay, let's stay here. One thing that often, or we get a feedback very, very often, and this I'm going to quickly demo that, was about how can I, as an application developer, kind of augment information that is sent to the client, especially in error cases. And right now we have an API, service on error, which you can implement. Just one of the big problems with that API is that we have to invoke it whether in all situations. If the request comes in and is already malformed, for example, and not even dispatched to a CDS service instance, we kind of make up a fake request that we can then hand into this service on error handler, so you can do stuff. And also you have to put every additional property that you want to send to the client, you have to prefix with an @ symbol, because then it's considered metadata by the OData adapter and is not going to get sanitized away. So these were things that was really bad for developer experience. So we now used the middleware's approach that we have. And maybe if you know it, you've probably always interacted with the before phase of these middlewares that are executed before the protocol adapter takes it. But actually, there's also an after phase, and this after phase was not very well integrated with the other adapters. So, but now with this new adapter and also with the REST adapter, they can be used. And I'm going to here have a very, very small server.js for S-Flight, where it just prepend our generic error handler with this one that does nothing but add like this hello property to the error and then calls again the next one, which is then going to be our generic error handler. And if we run this now, I mean, you probably believe me, but maybe not. So I'm going to prove it to you. So we're going to run S-Flight now. And you see that the first request up here looks pretty standard. Problem is I don't have an authorization header, so I'm going to get a 401 if I execute that. And this is exactly one of those examples. The request never went to any CDS service instance. Nevertheless, we had to kind of mock this situation to call your service on error handler. So it was very unclean. We put in a request object that was not a real CDS request object. We got feedback like, this is a little confusing. Why is this not a real one? Why don't I have a query? All these sorts of things. So we try to clear this up a bit. So if I now just execute this, and I'm not going to debug right now or stand, but you can see I just added whatever. I didn't have to prefix with it with any add or whatever. I can just augment this result if I want to. For responses, this may come. We're still on the looking for a use case if you really need that, because yeah, as you may know, we try to keep our APIs minimal and concise. And in the good case, I think we're pretty sure that the after handlers on service level are sufficient. So you don't need to have like this extra after middleware that you can hook into to manipulate the result. So that was one thing I wanted to show. Back to the slides. Oops. Okay, no, let's go directly stay in the demo. So next one I have is gonna be a delete request. I chose the delete because it's rather straightforward. It does a lot less than all the other middlewares actually. So I think it's best for this demo right now. So what we're going to do first is going to read the list of travels, get whatever travel UUID. I'm going to take this one, put it in this URL. I have debugger on, so I should breakpoints. Yes, I have breakpoints. Okay, so I'm going to send the request. And if you look now, so if we look at this briefly again, we went through the parse phase. We understood, okay, it's going to be a request to the resource I have here. Which was it? So from the processor, or actually the Traverse servers that's served at /processor, we have the travel entity, and then we have here some keys. It's draft enabled, so we have this is active entity true as well. So we parse this, understand this. There is no body in the case of a delete request, so it's rather straightforward. And then we kind of end up in this one, right? All the other ones get skipped because the request method is delete. And so now we end up here. And the parser actually added this underscore query object to the express request object. Oops, sorry. And in this underscore query object, we basically always have a selector. The parser is not aware of the method, so it will also just generate a select statement. It has a from clause, which is important for us because it has the path reference in it and also the keys. It has the target entity in there. And then we can kind of just mix in some information we need in the case of delete. So additional information we could be in the path segment beforehand. So if you delete via navigations, we have to extract all of these keys in the path and add it to reCAP. So because we have the API for your service handlers is that it doesn't matter what kind of event it is in reCAP, you're going to have, or in the case of read and delete, you're going to have the key properties of the entity. Then you see that we're going to have a query object we construct here. So either we delete from this path that we have determined, or actually, if you do a delete on a individual property, it's going to be an update statement, right? So stuff like this we have to handle in here. And at the end, we construct like the CDS request that we have here. And so you see the data is in there. We have different headers. What else is interesting? We have a delete request in requery, these sorts of things. What we also were able to introduce now is stable access to request and response of the specific request that is being served. And that's kind of the tricky part, which may be in the case of batch, which Fiori Element actually always sends. You're going to get under req-res or req-rec, you're going to get the sub request of that batch that is currently being served. That's especially helpful if you want to say set some headers on the result. So these are here, and I had planned to talk about that also, but okay, time's up, I guess, almost. But yeah, then what we do actually is
we can add one question now.
Yeah, I'm quickly gonna finish this one, right? Okay. Yeah, on conference stuff. So what happens here is kind of a little bit of magic. Yeah, is in case of a batch request, we would have opened the transaction outside using the new automatic transaction API. So in the old adapter, we did manual transactions exclusively, which was very error prone. Now we're doing automatic all the time. And this piece of coding here, the combination of service run and service dispatch, either joins an already existing transaction or creates a new one without you really seeing it here. So we're going to dispatch this request. We're going to get nothing result because we delete it, and then we send back to the client. Okay, totally out of time. I'm going to have some measurements. Yes, we're faster than the old one, but still preliminary. We have to measure again when we're totally done with it. And here, Outlook, it's going to be the default in CDS 8. Sorry. Guess I could have filled 40 minutes.
One question. Nobody? No, you were too fast. Thank you, Sebastian.